LSG is leader in lighting and electrical test instruments. Hello everyone, this is Daisy. Let me introduce to you the installation and use of the LSG-1800B, 1700B high precision rotation luminaire goniophotometer. The following is the video catalog. 1. System installation. 2. Candela calibration. 3. Measurement. 4. Notes. This video takes LSG-1800B model as an example. LSG-1700B will be slightly different, and the corresponding position to the video will be marked. Please check the packing list when you receive the shipment. There are 6 boxes in total. LSG-1700B has 5 boxes. Open all boxes and take out all equipment and accessories. This is the cabinet. It's used to place PM400 photometer, RT200 rotary actuator controller. LSG-1700B doesn't have RT200, LS series digital power meter, DC power supply and AC power supply. LSG has 3 models of digital power meters, LS2008R, LS2010, and LS2012. LSG has 3 models of AC power supplies, LSP series high precision AC power source, LSP VAR series AC power supply, LSPS series AC power supply. RS485 communication hub, RS485 USB converter and RS232 USB converter. Goniophotometer base. Turntable. LSG-1700B has already assembled the base and turntable when shipped. Socket and screws. FC200 angle controller. LSG-1700B doesn't have FC200. Detector holder, detector, and related accessories. Standard lamp. Calibration rod. Cross laser and its fixture. E27 fixture. Cross fixture. B-beta fixture. The various communication cables and power cords are in a separate package. Take them out for use. Products calibration certificates, warranty card, and CD. The CD contains the softwares, PDF version manuals and related standards. There is also a separate small accessory box. Please note that some of the above accessories are in the accessory box. A calibration set is needed during the installation and adjustment. The calibration set includes a spot laser, a small mirror, and a tripod. Software is required during hardware installation and adjustment. So we install the software first. Please prepare a computer with at least 2 USB ports. USB 2.0 black port is recommended, and preferably an English OS. Copy all files in the CD to the computer. Right-click to choose Run as administrator to install the software. The box of the RS485 USB converter contains a small CD with the driver. Double-click to install the driver of the converter. The cabinet needs to be placed outside the dark room and close to the goniophotometer. Open the door of the cabinet. Here is the power cord for the cabinet. Pass the power cord through the square hole at the bottom of the cabinet. The standard plug is Chinese plug. Please prepare a suitable adapter if it is used outside of China. Wiring diagram is posted on the back of the cabinet. Please install the PM400 photometer, digital power meter, RT200 rotary actuator controller, DC power supply, and AC power supply into the corresponding position of the cabinet according to the wiring diagram. Place the RS-485 communication hub in the cabinet. The top of the cabinet is equipped with a cooling fan. Connect the fan power cord to the wiring board inside the cabinet. Connect this plug also to the wiring board. Connect the power cords of all devices to the wiring board in the cabinet. Connect PM400 photometer, RT200 rotary actuator controller, LS digital power meter and DC power supply to the communication hub with short RS-485 communication cables. For AC power supply, if the model is LSP, it is also connected to the communication hub through a short RS-485 communication cable. If the model is LSP bars or LSPS, it must connect to the computer through the RS-232 cable and RS-232 USB converter separately. For LSG-1700B, there will be a long RS-485 communication cable, and the communication cable is marked with LSG-1700B. And the RS-485 communication hub also has a special communication port marked with LSG-1700B. Use that long RS-485 communication cable to connect the communication nub with the goniophotometer. In addition, there is a long RS-485 communication cable to connect the communication hub with the computer. If the computer does not have an RS-485 communication port, you can use the RS-485 USB converter. The yellow signal cable is used to connect PM400 photometer with RT200 rotary actuator controller. The yellow signal cable of LSG-1700B is used to connect PM400 photometer with RS-485 communication hub. Connect the 5 test wires to the terminals on the back of the power meter according to the diagram. Connect the DC power supply output cable to the terminals. Please note the polarities. Use the short 2-core banana plug wire to connect the AC power supply output to the terminals of load under test at the bottom of the cabinet. Please note that the output wires of the 3 model AC power supplies are slightly different. Prepare to install the goniophotometer base and turntable. Find this socket and its hexagon socket screws. There are same marks on the sleeve and the base. The 2 marks should be in the same direction. Install the socket as shown in the figure. Please take care of the cables. The cables should go through the side hole of the socket. Use the corresponding 4 hexagon socket screws to fix the socket. Remove the screws that fix the dust cloth on the turntable. The reserved cables of the goniophotometer need to be connected to the turntable. The turntable is very heavy. It needs at least 4 people to lift the turntable. The wiring terminals of the turntable need to be in the same direction as the reserved cables of the goniophotometer. And place the turntable on the base. Please note that another person is required to protect the cables at the same time so that the cables can pass through this position. 8 sets of hexagon socket screws and washers are used to fix the turntable. Fine-tune the direction of the turntable so that the turntable corresponds exactly to the 8 screw holes of the base. Please note that must use the 8 hexagon socket screws and washers provided by Luminaire. If you use different screws or washers, it may damage the goniophotometer. Fix the turntable, and connect the cables according to the labels. Then install the dust cloth back. Print out the darkroom drawing that Luminaire designed for you. The bottom of the goniophotometer is equipped with 4 universal wheels and 4 feet. Please rotate the 4 feet upwards and off the ground. Please note that there are 2 screws on each foot. You need to screw down the upper screw that locks the foot first, leaving enough space to turn the bottom screw upward to lift the foot off the ground. Then you can easily move the goniophotometer. Move the goniophotometer to the corresponding position according to the drawing. Place the position correctly to minimize errors. This side faces the detector. There are 2 arms on the goniophotometer turntable. This is the main arm. This is the auxiliary arm. Remove the 4 small screws of the auxiliary arm cover. And remove the 4 hexagon socket screws that fix the auxiliary arm. Remove the auxiliary arm and put it away. We will use it later. The accessory box contains a small black cover plate. Cover the position of the auxiliary arm with the cover plate and fix it with the original 4 small screws. The FC200 angle controller needs to be fixed on the wall later. And temporarily place it on the ground next to the goniophotometer. Assemble the detector holder and the detector. Place the detector to the corresponding position according to the darkroom drawing. And fix the detector on the top of the holder. The detector is fixed by rotation. Please tighten it as much as possible. This is the power adapter for the detector. There are 2 thin aviation plug wires. The short one is used to connect the goniophotometer with FC200. The long one is used to connect the detector with the PM400. 2 2-core long wires are used to connect the 4 terminals of the goniophotometer with the 4 terminals of the cabinet. A thick aviation plug wire is used to connect the goniophotometer with the RT200. There are 3 devices in the darkroom that need to be connected to the power supply: the goniophotometer, the FC200 and the detector. You can lead the power cable from the cabinet to the darkroom to supply power to the 3 devices. In this way, the power supply of the darkroom devices can be controlled by the cabinet. If it is not possible to lead the power cable from the cabinet into the darkroom, you can also connect the 3 devices in the darkroom to the power supply separately. In addition, the standard power cord plugs of these 3 devices are also Chinese-style plugs. Please prepare suitable adapters if necessary. There are grounding terminals on the back of the cabinet and the goniophotometer. Please connect grounding lines for the 2 ground terminals. After all wiring is completed, connect the system to 220V 50 Hz power supply. And turn on the cabinet, all devices in the cabinet and all devices in the darkroom. The detector doesn't have a power switch. Connect the power cord and it will automatically turn on. Connect the 2 USB cables of the cabinet to the computer. Right-click the LSG-1800B goniophotometer software icon. Select Properties, Compatibility tab. Select Run this program as an administrator. The first time you run the goniophotometer software on the computer, there will be a prompt window that tells you to run the system configuration first. Click Start. All programs. Listen. LSG-1800B goniophotometer. Right-click LSG-1800B System Configuration, and also select Run this program as an administrator in the Properties Compatibility tab. And then click to open LSG-1800B System Configuration. Select the model of the goniophotometer you purchased, click Auto Find Port. Select PM400, click Auto Find Port. Select LS series for the digital power meter model, and click Auto Find Port. If your power meter is LS2010 or LS2012 which is purchased long time ago, you may need to select the corresponding LS2010 or LS2012 for communication. The goniophotometer software can be run after all communication is successful. If the communication of some devices is not successful, please check whether the corresponding communication cable is connected correctly and whether the driver is installed successfully. You don't need to run system configuration first from the second time you run the goniophotometer software. But you need to repeat the above steps when the computer is changed. Regarding the angle of the goniophotometer, the goniophotometer rotates through 2 axes when it is running. The rotation axis of the turntable is the vertical axis. The axis of rotation arm is the horizontal axis. When the main arm faces the detector, the vertical axis is 0 degree. When the vertical axis rotates clockwise, the passing angles are 0 degrees, 90 degrees, minus 270 degrees, 180 degrees, minus 180 degrees, 270 degrees, minus 90 degrees, and 0 degrees. Do not place any debris on the goniophotometer to avoid affecting the rotation. Please note that there are emergency stop buttons on the RT200 and FC200. Please make sure that these two emergency stop buttons are released before you operate the goniophotometer. Open the goniophotometer software and click the rotary actuator control panel. If the vertical axis is not at the 0 degree position, enter 0 here and then click to rotate clockwise or counterclockwise to rotate the vertical axis to the 0 degree position. When manually rotating the vertical axis on this interface, there will generally be an error of about 0.1 degree which can be ignored. Make sure that the battery is correctly installed in the spot laser and it can be turned on normally. Install the spot laser to the horizontal axis of the goniophotometer. Tight the hexagon socket screw. Then turn on the spot laser. The laser point to the wall of the other end of the darkroom. Move the detector away. And use removable tape to paste a piece of white paper on the wall where the spot laser hits the wall. Rotary actuator control panel. Click the continuously rotate button below the horizontal axis. The horizontal axis and the laser will continue to rotate. Take a pen and trace the running track of the spot laser on the pasted white paper. Generally its running track is a circle. Rotary actuator control panel. Click stop. The horizontal axis and the laser stop rotating. Adjust the 4 small hexagonal screws of the spot laser to adjust the spot laser to the center of the circular track. Rotary actuator control panel. Click the continuously rotate button below the horizontal axis again. Continue to observe the running track of the spot laser. Repeat the above steps until the trajectory of the spot laser is a spot instead of a circle. Click stop after adjusting on rotary actuator control panel. Take out the cross laser and install the battery. There is a lock switch on the side of the cross laser, and always keep this switch at unlock. Then there will be alarm if the cross laser cannot be automatically leveled. There are power switch, horizontal laser, and vertical laser switch on the top of the cross laser. Install the cross laser on the tripod and turn on the cross laser. We need the horizontal laser. Place the tripod in a corner of the goniophotometer darkroom. Rotate the cross lasers so that the horizontal laser is aimed at the hole of the partition. Adjust the height of the cross lasers so that the horizontal laser pass through the center of the hole. Then rotate the cross laser to the direction of the goniophotometer. Rotary actuator control panel. Click the continuously rotate button below the vertical axis. The vertical axis starts to rotate continuously. Pay attention to the trace of the spot laser. Now we need to slowly adjust the height of the 4 feet at the bottom of the goniophotometer, so that the track of the spot laser coincides perfectly with the horizontal laser of the cross laser within the entire 360-degree rotation range. Please note that this step requires a lot of patience. After the adjustment, the 4 feet must be firmly on the ground to avoid moving. Then click stop on the software. Turn off the cross laser. Then lock the upper screws of the feet. Rotary actuator control panel. Enters 0 here. Click to rotate clockwise or counterclockwise to rotate the vertical axis back to the 0 degree position. Take a measuring tape to the partition closest to the detector. Confirm whether the laser passes through the center of the hole in the horizontal direction. If not, enter a relatively small angle for the vertical axis here, such as 0.1, 0.05, etc. Then click to rotate clockwise or counterclockwise according to the actual situation to make the laser pass through the center of the hole. Then now the vertical axis is at the correct 0 degree position. Click Set to 0. The password is LSG. Screw the small mirror onto the detector. Loosen this hexagon socket screw, and then you can adjust the height and direction of the detector. Loosen this screw to fine-tune the detector direction. According to the laser, adjust the height and direction of the detector roughly. Here 6 hexagon socket screws are used to adjust the detector pitch. Adjust these 8 hexagon socket screws so that the laser goes to the center of the small mirror of the detector, and the reflected laser returns to the original position. After adjustment, the 8 hexagon socket screws should all be tightened. Then fix the detector base on the floor to prevent the detector from being moved. The position of the detector may be moved slightly after fixing the base. Please fine-tune the 8 hexagon socket screws again and lock them. Remove the mirror after the adjustment. No need to set anything on the back of the detector. Remove the cross laser from the tripod and install it on the black metal fixture. According to the darkroom drawing, rotate the vertical axis and make sure the spot laser goes to the wall where the cross laser needs to be installed. Note that according to different drawings, the vertical axis may need to be rotated to 90 degrees or 270 degrees position. Turn on the cross laser and the horizontal vertical laser. Put the cross laser fixture on the wall in the direction shown in the figure. By moving the position of the cross laser and rotating the direction of the cross laser, the center line of the cross laser is completely coincident with the spot laser. Note that the cross laser can be automatically leveling and no alarm after adjustment. Then mark the screw positions of the fixture on the wall. Fix the cross laser fixture on the wall. It may be necessary to fine-tune the position of the cross laser after fixing the fixture. Loose the 4 screws that fix the fixture to move it left or right. Loose these 4 screws to move it up or down. Rotate the cross laser appropriately so that the center line of the cross laser is still completely coincident with the spot laser. Tighten all the screws after adjustment. Rotate the vertical axis back to the 0 degree position. The cross laser point to the opposite wall. Make a permanent mark on the opposite wall for the cross laser. When the cross laser is at this position, both the horizontal laser and the vertical laser pass through the center of the goniophotometer. You can turn off the cross laser after the adjustment. You can also remove the spot laser now. Install the LSG-200 on the same wall for easy operation. The hardware installation and adjustment is finished. Turn off the power of the system. Cover the equipment and clean the darkroom. Clean the goniophotometer system. Turn on the power of the system. We need to calibrate the system before using it. Turn on the cross laser, and rotate the cross laser to aim at the opposite mark. Confirm that the vertical axis is at 0 degrees position. Install the calibration rod in the center of the goniophotometer. Take out the standard lamp carefully. Connect the connecting rod. Install the standard lamp on the calibration rod as shown in the figure. The cross laser points to the center of the small mirror. Now we need to rotate the standard lamp rod. Adjust the pitch of the standard lamp to make the horizontal laser and vertical laser reflected by the small mirror coincide with the original horizontal laser and vertical laser. The cross laser still points to the center of the small mirror after the adjustment. Otherwise it needs to be adjusted again. This step also requires a lot of patience. After adjusting and fixing, gently unscrew and remove the small mirror. Turn off the cross laser. We need to rotate the vertical axis 90 degrees, and then make the standard lamp round hole directly face the direction of the detector. Please note that depending on the different design of the darkroom, it may need to rotate clockwise or counterclockwise. Rotary actuator control panel enters 90 here. Choose clockwise or counterclockwise according to the actual situation. This is the correct direction of the standard lamp after the goniophotometer stops rotating. There is a simple wiring diagram at the horizontal axis terminals of the goniophotometer. Please use short banana plug wires to short the red terminal with the yellow terminal, and the black terminal with the blue terminal as shown in the figure. Just connect the power wires to the red and blue terminals no matter it is a standard lamp or a sample lamp on the goniophotometer. Insert the standard lamp power cord plug into the red and blue terminals of the C-axis. Turn off other lighting in the dark room, and close the door of the dark room. The standard lamps of Luminaire are all constant current DC lamps. Please set the AC-DC switch of the cabinet to DC. This switch is the power meter sampling position switch. Always keep it at internal. The cabinet has two USB cables connected to the computer. One is the RS-232 USB converter for the AC power supply. The other one is the RS-485 USB converter for the communication hub. So the AC power supply uses one communication port, and all other devices use another communication port. Enter the computer device manager. You can see the two more communication ports at COM port. On software system configuration, the communication ports have been automatically searched for some devices before. So all of the goniophotometer, power meter, and DC power supply use this port. The other communication port is for the AC power supply. Find the calibration certificate of the standard lamp. We need the data for calibration. Click the DC button. When you use the software to control the power supply for the first time, a communication failure message may appear. Just select the DC model and communication port manually. Then enter the current and voltage of the standard lamp according to the calibration certificate. Check the CC constant current mode. Click Set. The DC power supply CC indicator is on, and the output current is exactly the same as the entered current. The voltage will fluctuate, which is normal. The real-time lux value can also be displayed on the photometer. Calibration should be done after at least 10 minutes preheating time. System configuration. There are two detector options here. The default is near-field detector. Usually one detector is enough for the goniophotometer. So if you only have one detector, do not check the far-field detector, otherwise the software will report an error. Click Candela Calibrate under the near-field detector. Enter the candela value of the standard lamp, and then click OK. The calibration distance will be automatically displayed here. The distance from the center of the goniophotometer to the detector can also be calculated according to the darkroom drawing. These two distances will be very close, but not exactly the same, which is normal. But if there is a big difference between the two distances, please contact us for help. Click Synchronize Calibrate Data to save the calibration data to the computer. Then click OK. The calibration is complete. Enter the DC control panel and click Reset to turn off the DC power supply. Since the current of the standard lamp is relatively large, the bulb will be very hot after use. Remove the standard lamp, put it back into the standard lamp box when it cools. Remove the calibration rod and put away. The accessory box contains a small black cover, which can be screwed in the center of the goniophotometer to cover the round hole for the calibration rod. You can write down the calibration distance. If you need to change the computer in future, you don't need to recalibrate if the darkroom is unchanged. Just input the calibration distance manually, and then click Synchronize Calibrate Data, OK. Goniophotometer has two test methods, single column C gamma test and double column B beta test. According to the standard, the floodlights need to do B beta test, and other types of lamps need to do C gamma test. Users can also refer to local standards and do corresponding tests for your samples. Here are the steps for C gamma test. LSG provides two C gamma test fixtures: E27 bulb fixture and large cross fixture. These two fixtures can usually hold most of the luminaires for C gamma test. We can also design other fixtures for you if you have special luminaires to test. Install the corresponding fixture to the horizontal axis of the goniophotometer. Turn on the cross laser and aim at the mark on the opposite wall. Open the software and rotate the vertical axis to make the cross laser face the fixture. Install the sample according to the cross laser. Make sure that the cross laser center point at the center of the luminous surface of the sample. Rotate the vertical axis back to the 0 degree position after installation and fixation. Now you need to rotate this handle to move the luminous surface of the sample to the vertical laser. That is the center of the goniophotometer. LSG-1700B doesn't have this rotating handle. There is a hexagon socket screw under the main arm to fix the main arm. Loose this screw counterclockwise to slide the main arm. Use the banana plug to connect the power cord of the sample lamp with the red and blue terminals of the horizontal axis. Then you can turn off the cross laser. Turn off other lighting in the dark room. Close the door of the dark room. Take the AC sample luminaire as an example. Set the AC/DC switch of the cabinet to AC. Click the AC button. When using the software to control the AC power supply for the first time, you also need to manually select the AC power supply model and communication port. Enter the correct frequency and voltage, and click Set. If Set is not available, please click Reset first. Then the AC power supply start output and the power meter displays the electrical parameters. The sample is on now. Click Measure. The first step is to fill in the sample information and test information. You can also fill in after the test. Click Next. Select the type of lamps. Flood is B beta test. Indoor and roadway are C gamma test. Set the test parameters. C plane is the horizontal axis angle. G plane is the vertical axis angle. C plane symmetry options. If there is no special requirement, please always select no symmetry and no need to change. The rotation range is from 0 to 180 degrees and no need to change. The angle interval is optional from 0.1 to 90 degrees. The principle of selecting the interval is basically as follows. If the sample lamp is symmetrical and uniform, bulb, panel lights, etc., you can choose a bigger interval such as 30, 45, etc. Otherwise, street lamps, etc., you need to choose a smaller interval, such as 10, 15, etc. Bigger interval need less time to finish the test. Smaller interval need more time to finish the test but the data is more accurate. G-plane. There are two options for the rotation range. -90 degrees to 90 degrees is for samples with an illumination angle less than 180 degrees, such as down lights, panel lights, etc. -180 degrees to 180 degrees is for samples with an illumination angle greater than 180 degrees, such as various bulb lights. According to some standards, it is also need to test the backlight of the samples even the illumination angle is less than 180 degrees. Then just select -180 degrees to 180 degrees for G-axis rotation range. If there is no special requirement, always select 1 degree for G-axis interval. There are two preheating options. You can directly input the preheating time. You can also check auto preheat. So the software will automatically monitor the stability of the intensity of the sample in accordance with the standard requirements. The software will automatically run test after it is stabilized. Check this option, the vertical axis will automatically return to the 0 degree position after the test. The software will automatically save the test results. Just select the path where you want to save. Enter the file name here. Check Add suffix automatically. This function is to avoid the situation that the previous test result file is overwritten if you forget to modify the file name. Click Next. If the communication of the power meter is normal, the electrical parameters of the sample will be automatically displayed here. If this option is checked, the power meter will communicate again and use the latest data after the test. Click Start to start the test. If the preheating option is checked in the previous step, the software will enter the preheating interface after clicking Start. And the test will start automatically after the preheating is over. Depending on the range and interval of the C-gamma angle you choose, the test process may take about 10 to 30 minutes. The test results are displayed in the software after the test. In addition, pay attention to the direction of installation if you test a street lamp. When the C-axis angle is at 0° position, it needs to be installed on the cross fixture in the direction shown in the figure. The direction of the pole side of the street light needs to be upward. And select roadway here. The other steps are the same. As mentioned before, floodlights need to be tested by B-beta. The auxiliary arm is removed during installation and adjustment. B-beta testing requires the auxiliary arm. Rotate this handle, and move the main arm to the farthest end. Install the B-beta fixture, and then rotate this handle so that both ends of the fixture are embedded in the two arms. Lock this handle. When the horizontal axis is at 0° position, the fixture should be vertical as shown in the figure. Lock the two hexagon socket screws on the two arms to fix the fixture. If the cross laser is at 270° position of the vertical axis, as shown in the figure, you can directly turn on the cross laser, and install the floodlight according to the cross laser. Just make sure the cross laser is at the center of the luminous surface. If the cross laser is at the 90° position of the vertical axis, you need to rotate the vertical axis to the 180° position, and then turn on the cross laser to install the light. During the B-beta test, the sample is easy to fall. Please be sure to tighten the sample when installing. For heavy floodlights, it is necessary to bind the sample to the fixture. Use banana plugs to connect the power cord of the sample to the red and blue terminals of the horizontal axis. Then turn off the cross laser. Turn off other lighting in the dark room. Close the door of the dark room. Select flood for lamp type. The software will automatically change to B-beta test. B plane is the horizontal axis, and beta plane is the vertical axis. If there is no special requirement, select no symmetry as well. The rotation ranges of B plane and beta plane are no need to change. From -90° to 90°. The principle of B plane angle interval is the same as C plane. The principle of beta plane angle interval is same as G plane. Other settings are same as the C gamma test. Click Start to start the test. After finished the test, you can view the test data immediately. If you need to export files in other formats, click File Export. Select the required format and export it. Click Print option to view and modify the print options. Check the parameters you need to print to the test report. Click Print to select PDF or the printer to print the test report. Please build the darkroom exactly according to the design drawings provided by Luminaire. And note that the paint is matte black. Do not place any debris on or around the Goniophotometer. Both RT200 and FC200 devices have emergency stop buttons. Please make sure that both buttons are released when you use the Goniophotometer system. These two devices can also control the angle of the horizontal axis and vertical axis of the Goniophotometer. Usually you don't need to use these two devices because it is much easier to control the angle in the software. If you want to operate them, you can refer to the button function prompts on the device. We will update the Goniophotometer software irregularly to meet the latest standards and add new functions. We will guide you to update if there is newer version software. Thank you for watching.